Hello everyone, in this video we are going to talk about the worksheet 10.1a level 2, which is talk about the circle property, angle at the center, twice angle at the circumference. So if we look at this circle, first of all we got this angle x together with this angle y. We can say that the angle x is actually the angle at the center, and the angle y, which is the angle at the circumference. So if we clearly look at this, so first of all, we can say that the axis actually as an eye is watching this arc, AB, isn't it? And actually, for this angle y is watching the same arc as well. So if we say that in a circle there's two angles watching to a same arc, then we can say there's a relationship between them, and the angle at the center is actually twice angle at the circumference. So we have the larger angle at the center part. So for the proof of this theory is actually after this solution. So if you have any ideas, or if you aim for level 4 or level 5 and above, then try to understand the proof of different kinds of this angle at the center, twice an angle at the circumference. So let's do the first one. So now we have this 72 together with this x. So 72 is our angle at the circumference, is angle at the center, and x is the angle at the circumference. So just using our theory directly, we have the angle at the center, which is 72 degrees, is doubled the twice of the angle at the circumference, which is x. Then we can say that the x is equal to 72 divided by 2, so we have this is equal to 36 degrees. So now we have the second type. We still have our y as the angle at the center, and the 40 is the angle at the circumference. So we use that equation again. The angle at the center, which is y, is equal to twice of the angle at the circumference, which is equal to 40. Then we can say that y is actually equal to 80 degrees. So for 1c, we have this is very large angle M, and if you still remember that for the angles, if the angles is greater than 180 degrees, which is calling the reflex angle. So this is the reflex angle AOC, we call it as an M. So this M is actually watching the whole major arc AC, and so do this 126. So both of the M and the 126 is watching to the same arc. So that there's a relationship between them, then we can use the angle at the center twice the angle at the circumference. So our M is the angle at the center, which is twice angle at the circumference. So we have the M is equal to 252 degrees. So for the last one, this is like a butterfly. And then we got our 74 is the angle at the center, and the N is the angle at the circumference. So we say that the 74, the angle at the center, is equal to twice angle at the circumference. So we solve for this, we got the N is equal to 37 degrees. So then we can do question 2. So for question 2 is asking about where is angle BAC, and we have the AO is perpendicular to BO. So we understand the question first. The AO is perpendicular to BO, which means that we have a right angle here, and we got our angle BOC is here. And what is the angle that we're going to find is the angle BAC. So if we want to find out BAC, we need to locate it first. So angle BAC. So this is our angle BAC. So we located it. So now we have this angle BAC is watching to this arc, and this arc is actually watching by this BOC as well. So there's a relationship between the angle BOC and the angle BAC. As the angle of BOC is the angle at the center, so that we have the angle BOC is equal to 180, which is equal to the double of the angle at the circumference, which is angle BAC, so that we have the angle BAC is equal to 60 degrees. So for the next question is asking about what is the angle of ABC. So we locate it again. So angle ABC is actually here, angle ABC. So this angle is something that we want. So if you want to find out this angle, which means that you must have this angle as well, because we got the angle of BAC, and this is what we want. So if we have this angle as well, then we can use the angle sum of triangle to find out what's the answer of the question required. So what we want is this one, we give a question mark, and what we need is angle BCA as well, so we give a question mark as well. And so do we have angle BAC? Yes, we calculated in part A, which is 60 degrees, so this is 60 degrees. And how can we find out angle BCA? So if you find out angle BCA, then we find out the answer for these questions. So if you want to find out the angle BCA, then what you're going to use is this right angle. Why? Because this angle is watching to AB, this right angle, isn't it? And so do this angle BCA is watching the same arc as well. So there's a relationship between them. So at the first part, we can say that the angle BOA is equal to 90 degrees, which is equal to the double of the angle BCA. And the reason for this is angle at the center twice angle at the circumference. So now we say the angle BCA is equal to 45 degrees by using 90 divided by 2. Then we can say that the angle of ABC plus 60 degrees plus the 45 degrees, which is equal to 180 degrees. So again, if you look here, we got our angle ABC, that what we want in part B, and we got angle BAC, which is 60, and we got angle BCA, which is 45. Then these three angles plus together, we give you the 180 degrees by using the recent angle sum of triangle. Angle sum of triangle, so that we have the angle ABC is equal to 180 minus 45 minus 60. This one will give you 115 degrees. So that's for question 2. And now we can move to question 3. Now we have the BA is perpendicular to OC. So locate two parallel lines. We have BA is parallel to OC. And we have this angle 65. The question is asking about the reflex angle BOC. So where is BOC? So this is our BOC. So it's this angle that we want to find. No, because this angle is not greater than 180, which is not a reflex angle. So it's actually representing to this angle. This is our reflex angle. So this is the angle that we want. So if you want to find out the angle of this, which means that you need the angle of BAC, because angle of the BOC, which is at the center, is doubled the angle at the BAC, which is at the circumference. So if you want to find out BOC, what you need is this BAC. So how do you find out BAC? As AB is parallel to OC, so there's a relationship of their interior angle, which is the angle BAC that we want, and 65 that is already provided. So the first line we can gonna write is, we have angle BAC plus the angle ACO is equal to 180. The degree for this, the reason for this is the interior angles, and we have two parallel lines. The AB is parallel to OC, so that we can say the BAC is equal to 180 degrees minus 65 degrees to give you 115 degrees. So now we get the answer of BAC. So now we can use the angle at the center twice the angle at the circumference. So we have the angle BOC is equal to the twice of the angle at the circumference, which is angle BAC. Then we have this is equal to 115 times 2 will give you 230 degrees. So for question 4, now we have an angle OAD. This is 25 degrees, and this CBD or BDC is actually equal to 110. So the question is asking you to find out the angle of CBD. So CBD, that's something we want. That's something we want, so we highlight it and then we give a question mark there. So now we can analyze this circle. So angle CBD is actually same as the angle ABC, isn't it? And the angle ABC is actually watching to the arc AC, and this arc is being watched by this angle AOC as well. And the angle AOC, which is the center angle, and the angle CBD is the circumference angle. So the angle at the center is twice the angle at the circumference. So the first line we can write is the angle of AOC is equal to the double of the angle of CBD. Alright, then how can we find it out? So if you want to find out the angle of AOC, what you want to use is this angle OAD, this angle together with the angle ADO. So the angle of ADO is actually the opposite angle of CDB. So that we can just using the opposite angle first, we can write down the angle of ADO is equal to the angle of CDB, which is equal to 110 degrees, and the reason for that is the opposite angle. So now we got this angle, which is 110 zeros, and we have this DAO, which is 25 degrees. So we have the angle AOD plus 25 degrees plus 110 degrees, which one will give you 180 degrees. So that we have the angle AOD is equal to 45 degrees. So now we find out what is the value at the center, then we can find out the angle at the circumference as well. So now we have the angle at the center, which is angle of AOD, which is equal to 45 degrees, is equal to the twice of the angle at the circumference, which is CBD. So that we have the angle CBD is equal to 22.5 degrees. So moving to the last part, we have our OBC is equal to 33 degrees. We have AOB is equal to 120. So how can you find out the angle CAO? So how you find out this angle? So it's actually quite hard for the normal student to do it. So if you aim for level 2, then you probably don't know this one is fine. But if you're aiming for the higher one, then try to do it as well. So when you see some of the question you don't know how to do with, then try to add some lines to it. So for example, if you're adding a line joining the C and O, then actually we got 3 radii as they are the same length. So we have OC equal to the OB together with the OA. We don't have the length exactly, but we can just use the property that they are the same. So now we have OA equal to OB is equal to OC, so those are their radii. So when you have a radii here, which means that we have a isosceles triangle, so we have the base angle are the same, so angle OCB is actually equal to 33 degrees as well, and together with anything else that we can find it out, and we have this angle of ACO is equal to the angle of CAO as well. So what's the angle that we want is the angle ACO. So this is the angle what we want. So which means that if we find out the angle of ACO, then we got our final answer. So if you want to find out the angle of ACO, so this angle ACB is actually half of the angle of AOB. So the first line we can write it as, so we write down the base angle isosceles triangle first. We have the OB is equal to OC, so that the angle of OBC is equal to the angle of OCB, which is equal to 33 degrees. And the reason is the base angles isosceles triangles. And now we have the angle at the circumference is half of the angle at the center. So now we have the angle of ACB is actually equal to 120 divided by 2, give you 60 degrees. So this is we calling as the angle at the center twice angle at the circumference. So now we got the whole angle connecting with 33 and the variable is equal to 60, so that we have the angle ACO is equal to 60 minus 33 to give you the answer is 27 degrees. So again, as the OC is equal to OA, so that we have the isosceles triangle, so we have the angle of OCA is equal to the angle of CAO, which is equal to 27 degrees. And the reason is the base of the angles isosceles triangle. So that's for this worksheet. If you have any question, don't hesitate to ask me. So after that, I'm going to talk about the proof of this theory. So if you're aiming not for level 4 above, so just leave it. Or if you have an interest in it, so try to understand it as well. So the first case is an arrow. So as again, we just draw a straight line first. If you draw a straight line cutting through the whole thing, all the way to draw a diameter to cutting through the whole thing, then if we say that this is our A, this is our B, this is our C, and the center is O, So if we decide that the angle of ABO is actually A, and the angle of the CBO, which is B, so now we got this AO equal to BO equal to CO. So now we have the angle BAO is equal to A as well, and the angle of BCO is equal to B as well. So that we can using the exterior angle to get the value here together with this. So we try to write something. So now we can say that the OA is equal to OB equal to OC, which are the radii. So now we can say that the angle of ABO is equal to the angle of BAO, which is equal to A, and the angle of BOC is equal to the angle of, BCO is equal to the angle of CBO, which is equal to angle B. And now we can say that, so what is this point? So the angle of, if we call it this is D, if we have the angle of AOD, which is actually equal to A plus A, give you 2A. The reason for that is the exterior angle. And then now we have the similar one. We have the angle CBD is actually equal to, the angle of COD. So this is something that we want to find. So angle of COD is actually equal to the angle of BCO plus the angle of CBO, which is equal to B plus B give you 2B. The reason for that is still the same, the exterior angles. Then we can say that's so we have the angle of AOC is equal to 2x plus 2y, which will give you, taking out the common factor 2, we have x plus y. So x plus y is actually angle of the circumference. So now we can say that this is equal to 2 angle of the ABC. So we have the angle at the center twice angle at the circumference. So try to do the rest free profile yourself, and if you have any questions, just don't hesitate to ask me as well. Okay, thank you.